Welcome to another Win with Math video. Today's video will be solving the system with three different methods. The first method being substitution, second method being elimination, and the third method being Cramer's rule. The first two methods is what you will see in Algebra 1, whereas the third method is what you will see in Pre-Calculus. Now let's solve the problem. Since we're solving for a system with two variables x and y, then we want our solution in ordered pairs x, y. For method 1, when we're solving for substitution, we want to look at both equations and see which equations makes it easier to solve for a variable, particularly 1x or 1y. And we notice the second equation has a 1x. So we'll take this and we'll add 4y to both sides to get x by itself. So x equals -5 plus 4y. Then we take the first equation and we'll substitute x equals -5 plus 4y into the equation. And then we'll distribute the 2 to get -10 plus 8y. And then we'll combine like terms. 8y plus 3y is 11y. Then add 10 on both sides to get 17. And finally, divide both sides by 11 to get y equals 17 over 11. Then we need to solve for x. Since we have that x equals -5 plus 4y, we're going to substitute y equals 17 over 11 in. And then 4 times 17 will give you 68. So that will be 68 over 11 for 4 times 17 over 11. And then -5, we want a common number 11. -5 is -55 over 11. And then -55 plus 68 give you 13, and that's all going to be over 11. So x equals 13 over 11. So our ordered pair is going to be 13 over 11, comma 17 over 11 for x and y respectively. So you solve for both x and y, and you got your answers, 13 over 11, comma 17 over 11 for x and y. And you're probably wondering, did we do it correctly? Well, you should have a good habit of just checking your work. So let's check our work. So we have the first equation, 2x plus 3y equals 7. We'll substitute the x and y values, and then we'll simplify, and then add them up and simplify. So we get 7 equals 7, which is true. So we know that the x and y works for the first equation. We should also get a habit of doing it to the second equation as well. So here's x minus 4y equals -5. We'll substitute the x and y values. We'll simplify, simplify, simplify. We get -5, which is true. So we have verified that x equals 13 over 11 with the corresponding y equals 17 over 11 is a solution to this system. Now let's get into method 2, elimination. Just like method 1, we'll need our solution in terms of an ordered pair x, y. So the idea here is we want the coefficients for either the x or the y to be the same but opposite signs. So we notice that there is a 2x and a 1x. So if you multiply the second equation by -2, we're going to get -2, so we can just add straight down. So here's the first equation. We'll multiply the second equation by -2, so we get -2x plus 8y equals 10. You want to make sure you check here that you multiply the second equation by -2 correctly. Then after that, we'll add straight down. The 2x minus 2x plus a -2x should cancel to be 0. And then 3y plus 8y gives you 11y, and 7 plus 10 give you 17. Then divide both sides by 11 to get y equals 17 over 11. Then we need to solve for x. So we'll choose the equation with the 1x to make it a little easier, which is x minus 4y equals -5. We'll add 4y to both sides, and then we'll substitute in y equals 17 over 11. 4 times 17 over 11 give you 68 over 11, and we want a common number 11, so -5 is -55 over 11. And then we'll simplify to get 13 over 11. So here we found our solution with elimination. Still, x equals 13 over 11, and y equals 17 over 11. For method 3, Cramer's rule, we still want our solution x, y. So we'll first need to set up our d, which is our determinant. First, we're going to have our coefficient for the x, which will be 2 and 1, and we're going to write it this way. Then we want our coefficient of y, and we're going to write it 3 and -4. Next, let's solve for the determinant of this 2 by 2 matrix. So we have 2 times -4, and then we're going to subtract off 3 times 1. Simplify this, and we get d to be -11. Next, we need to solve for d of x, which is the determinant for solving for x. So what we're going to do is we're going to keep the y column by itself, the 3 and -4, but instead of having the 2 and the 1, we're going to replace the 2 and the 1 with the constant, which is the 7 and -5. And then we'll do the same thing what we did to solve for D. We'll take the 7 and multiply by -4, then subtract 3 times -5. Simplify, and we get -13. Lastly, we need to solve for D of y. So, since we're solving for D of y, we're going to keep x the way it is, which is the 2 and 1, but we're going to replace the y column with the 7 and -5. Then we'll solve for the determinant, so we have 2 times -5 minus 7 times 1. Simplify, and we get -17. So now that we have D of x, and D of y, we can solve for x and y. So x is going to equal to D of x divided by D. And then we'll substitute those values in, so -13 over -11, and that simplifies to 13 over 11. And then to solve for y, we'll do y equals D of y over D, which is equal to -17 over -11, simplify to 17 over 11. So our ordered pair will be 13 over 11, comma 17 over 11. And this is our solution. You can extend this method with 3 equations with 3 unknowns, so we can solve that a little bit more quicker. If this video helped, give it a like, subscribe for more, click on the video on screen to keep learning. Thank you.